Resolving vectors into components means I need to find the vertical and horizontal, or x and y components of a single vector. So if I take a look at this problem, I have a helicopter traveling 95 kilometers an hour at 35 degrees below the horizontal. Well, I can go below the horizontal to the left or below the horizontal to the right. I'm going to go this way. So here's my angle, it's 35 degrees. First thing I've done is I've sketched the vector on my diagram, so I know which way it's pointing. And now I need to find the vertical and the horizontal components. So what I need to find the vertical component, so the distance between the tip of the arrow and my x-axis, and I need to find the horizontal component, which is from the tip of my arrow back to the y-axis. So here is Vx, here is Vy. Vy points down because this arrow is going down and to the right. Vx is going to the right because this arrow is pointing to the right and down. So how do I find my components? Well, Vx is right next to my angle. The hypotenuse of my angle is what I know this time, so it's 95 kilometers per hour. So trigonometry allows me to take the hypotenuse and a trig function to find that side of my right triangle next to the angle. And the trig function I want to use is the cosine. So I'm going to take my hypotenuse, 95 kilometers per hour, and multiply it by the cosine of 35 degrees. And so what I find for Vx is I have 77.8 kilometers per hour. Vy, or the vertical component of this particular vector, at least visually on this graph. Again, I'm going to use the hypotenuse, and this time I want the side that's opposite my angle, my 35 degrees. So trig function means I use sine. So I'm going to set it up the same way, 95 kilometers per hour times the sine of 35 degrees. And this time I get negative 54.5 kilometers per hour. Why is this negative? I chose in this particular problem to make up positive, therefore down is negative. I also chose in this particular problem making right positive, therefore left would be negative. Your signs could be different from mine depending on what convention you choose for positive and negative. So now I want to add vectors that are not perpendicular to each other. So similar to when we had two vectors, one east, one west, now I'm going to add two vectors, but they're not at right angles to each other, so I can't use Pythagorean theorem. I have to do a couple of steps before I can add them. So first of all, I have a hiker walking 25.5 kilometers at 35 degrees south of east. So there's my first one. Here's 35 degrees, and it's 25.5 kilometers. The next day she walks 41 kilometers at 65 degrees north of east. So here is my second vector, 65 degrees north of east, so there's my 65 degree angle, and this is 41 kilometers. So the first step, draw the vector diagram. And now what I need to do is I need to put together a vector sum. Where is this thing going to end up? So there's the first vector, here's the second vector, there's the third vector. So our resultant vector is there. So she's going to end up a bit north of where she started and significantly east of where she started. So how do we figure out mathematically where she's going to end up? Well, I have to do what's called resolving the components. So what I'm going to do is I'm going to find the displacement actually, of each vector in the x direction and in the y direction, and I add the x terms and I add the y terms. So let's take a look at how that works. All right, so we have delta x, or the displacement of the first one, is 25.5 kilometers. And we get 20.5 kilometers for the first one. The second day, our change in position, or our displacement, is going to be 41 kilometers times the cosine is 65 degrees, and I get 17.3 kilometers. Change in position in the north-south direction, I get 25.5 times the sine of 35 degrees, and I'm making that south direction negative, so it's going to be a negative 14.3 kilometers. For my other second day travels, delta y is going to be 41 kilometers times the sine of 65 degrees, and I get 37.2. So to the right is positive, up is positive, down is negative. So now what I'm going to do is I'm going to add these two. So I get 37.8 kilometers, and it's positive, so it's to the east. I'm going to add these two, And what I get now is 22.8 kilometers. It's positive, so that's to the north. So now what I can do is I can draw my two resultants in. So I'm going to the east for 37.8 kilometers. And then I turn and head north and I go 22.8. So I started here, first day, my trip begins there, I end here. So there is my resultant, and so my lines look similar to what was drawn up above. It's just that they're hand-drawn now and they're rotated a little bit, so I'm looking at a right triangle. So now I can find my resultant because I have a right triangle. I can do a Pythagorean theorem and I can find R. So 22.8 squared plus 37.8 squared, find the square root of that, I get 44.2 kilometers. So that's my resultant. I want to find this angle. So again, I can use tangent, or I can use sine, or I can use cosine. Any of those are fine. I tend to prefer tangent. It's just easier and for me a little bit more obvious. So the tangent of my angle is going to be 22.8 over 37.8. So my angle is going to be 31.1 degrees. So I can either draw the diagram as shown and show where my angle is, or I can say that it's 31.1 degrees north of east. So if I write it and don't do a diagram, I have to include the direction so I know which way my 31 degrees is pointing.